All right, welcome back, everybody. So I am up here at my board right now. So sorry if doesn't sound like my normal videos because I'm up at the board rather than at my tablet. So might sound a little bit different, but that's okay. It's actually like 15, 20 minutes after I got done with my seventh period. Still in eighth period on Friday. All right, so let's take a look at number 6. Let's find f of g and then g of f, and then we're going to state their domains. So if I want to find f of g of x, that means I want to find f of, and then g of x is x squared plus 2. So let's take x squared plus 2 and plug it in for f. So that's 3 minus 4 times x squared plus 2. And then I have to evaluate that, which is going to be 3 minus 4x squared minus 8. So all said and done, negative 4x squared minus 5. I should be double checking my answers just in case I don't want to make any mistakes on these videos. Negative 4x squared minus 5. All right, so now I'm going to take a look and see my domain. Negative 4x squared minus 5 has to be greater than or equal to 0. So I add 5 over to the other side. Negative 4x squared is greater than or equal to 5. And then I divide by negative 4. So x squared is less than or equal to negative 5/4. Ooh, this is interesting. This is interesting here because can a squared ever come out to be negative? No. What do I have in my key here for the domain? Oh, the domain. Ooh, this is interesting because the domain is actually no solutions because there's nothing I could ever square to make it positive or square to make it negative. Interesting here. So that's actually my domain because we would be listing this process lists the possible values of x, that x has to stay greater than or equal to 0. So x would have to x squared would have to be less than or equal to a negative 5/4, which cannot happen. So that's why the domain is no solutions. Don't worry, I believe I'm speaking from experience here. That doesn't happen on the test, but that's what would be the case here. I think what's making it weird is that I've got a squared and a square root, which kind of throws it off a little bit. All right, let's find g of f of x. Let's leave that one behind. So that means I want g of radical 3 minus 4x. Okay, so that means I'm going to take radical 3 minus 4x squared plus 2. Okay, so that removes the x squared. So that removes the squared there. So it's 3 minus 4x plus 2. So negative 4x plus 5. Now remember, for the composite, negative 4x plus 5, for the composite, what you have to do is look at the innermost function first and then apply the domain in the end. See, now you might be tempted to say that the domain is all real numbers because looking at the very final answer, it's saying, oh, well, then I don't have to have any restrictions on it. However, if I look at the innermost function, which is f in this case, I have to say 3 minus 4x has to be greater than or equal to 0. Okay, so when I subtract the 3, I get negative 4x is greater than or equal to negative 3, divided by negative 4, switch the sign, positive 3/4. X has to be less than or equal to positive 3/4. So then I say, well, I have to take that domain and see if I need to tweak it at all or restrict anything more based on the final. And I don't. My restriction is already there. So my domain is negative infinity to 3/4 inclusive. Just double check that answer. Yep, negative infinity to 3/4. All right, there's 6. Let's take a look at number 7. Using the chart, evaluate the following compositions. All right, so g of 1. So what I'm going to do here is I'm going to look at g of 1. I see that g of 1 is 6, and then I say, okay, I want to find g of 1. So g of 6. Oh, sorry, that's a g. G of 6. Oh, it's right there. It's right underneath it. G of 6 is 3. So this all said and done is 3. Let's put the next one in red here. G of f of 3. So I want to evaluate f of 3 first. So f of 3 here is 4. So I want to find g of 4. That's what it's going to evaluate with. So g of 4 is 1. And then I want to find f of 1. So f of 1 is 3. So f of 3 is, look, there's 4. Those are my answers. Let me just double check. I got 3, 1, and 4. That's what I got on my key. Perfect. Next one up. All right, no calculator again. Or no graphing calculator. Log base 9 of 105 minus log base 9 of 7 minus log base 9 of 5. Okay, that's going to mean log base 9 of 105 over 7. I'm going to evaluate that first. And that's going to be 105 over 7. See, I can just take that in my calculator, 105 over 7. I can have the red calculator, so I can divide. So it's going to be log base 9 of 15 minus log base 9 of 5, which is log base 9 of 15 over 5, which is log base 9 of 3. Now, looking at it this way, I want to know what that evaluates to be. Think about it. 9 to the what power is 3. What would reduce it like that? Well, isn't that square root? How do I write a 1/2? Oh, I just gave it away. How do I write a square root? That's a 1/2 power, right? That reduces all the way down to 1/2. Let me double check answer. Yep, 1/2. Next one up. Find the inverse. Okay, so remember this is y is equal to 4x minus 1 over 2x plus 3. So it's going to shift into x is equal to 4y minus 1 over 2y plus 3. Now remember the technique for this, we did this in the notes that one day. Multiply over the 2y plus 3. So like so. And then distribute in the x. 4, that's a 4y. And then I jump all the y's to the left side. Subtract the 4y to the left. And then I have to get that 3x over to the right side. And now I factor out the y. And then divide by 2x minus 4. And that's f inverse. And if I'm using the correct notation there, I'm going to say f inverse of x equals. Cool. Let me just double check. 4y 9. Oh, I was looking at the original problem. Negative 3x minus 1, 2x minus 4. Perfect. All right, find an expression for tangent of cosecant negative or inverse cosecant of radical x. Now, I kind of threw you an oddball here with cosecant, right? Remember that cosecant is the reciprocal of sine, right? Cosecant is the reciprocal of sine. And so cosecant, since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, right? Okay, so that means that if I know cosecant, inverse cosecant of radical x is equal to some theta, then I know that radical x is equal to cosecant theta, radical x over 1. So draw out your triangle. Let's label theta. And that's going to be, okay, so hypotenuse over opposite, hypotenuse over opposite, hypotenuse over opposite. Now, I need to evaluate tangent theta, right? Because if cosecant radical x is equal to theta, I need to just plug theta back in here and find tangent theta to see what I would get over here. All right, so tangent theta is opposite over adjacent, so I need to figure out what adjacent is. So a squared plus 1 squared is equal to radical x squared. All right, so that radical x squared goes to x. So a squared plus 1. So a squared is equal to x minus 1. So a is equal to radical x minus 1. So that means the opposite is 1. The adjacent is radical x minus 1. I also gave the answer as rationalized radical x minus 1 over x minus 1, but I'm good with 1 over x minus 1. All righty, keep chugging along. If 2 ln of x is equal, or sorry, if f of x is equal to 2 ln x plus 3, find the domain and range and the x-intercept. All right, so I have to think about it this way. What are the transformations happening here? This is a vertical stretch by 2, and then an up 3. Now think about it as ln of x. ln of x, just the parent ln of x, looks like this, natural log. Maybe not so much curve in on the bottom. But all I'm doing here is just shifting it 3 units up, right? I'm shifting it 3 units up. 1, 2, 3. And so this point goes to here, like that, right? Does the domain and range change at all from the parent to the original? Nope. So the domain is 0 to infinity. X is going 0 to infinity, and the range is all real numbers. Now the x-intercept, that's where it gets a little bit more difficult, because I know that it's going to be x comma 0, right? X comma 0. 2 ln of x plus 3 equals 0, and I've got to solve that equation. Subtract the 3, divide by 2. Now I have to turn it from logarithmic into exponential, so e to the negative 1.5 is equal to x. So, if you were going to get exact, e to the negative 1.5 comma 0, sorry, not negative e, e to the negative 1.5, 1.5, sorry for my poor handwriting, comma 0 is my x-intercept, but if I wanted to put it as a decimal, e to the, e to the negative 1.5. 0.223. 0.223, comma 0. Just going to double check. Yep, 0.2231 I had. Okay. Ooh, interestingly enough, I had the square root of e to the negative third. Oh, yeah, that's e to the negative 1.5. All right, so looking at 12. Look, I got 12 and 13 on this one. Okay, 12. I'll put 12 over here. Solve e to the 2x minus 1 equals 3. All right, so since it's in exponential, I'm going to put it in logarithmic. Log base e, or ln, of 3 is 2x minus 1. Now, easy enough. Add the 1. Divide by 2 is equal to x. So I'm going to do ln 3 plus 1 divided by 2. 1.05. Let me double check. 1.05. Approximately 1.05. Looking at 13. Okay, we got ln of x squared plus 2 equals 7. All right, so I'm going to again take it from logarithmic into exponential. E to the 7th is equal to x squared plus 2. Subtract 2. Square root. Plus or minus, right? Yeah, plus or minus. That's equal to x. So now I go in and I actually evaluate that. E to the 7th minus 2, square root it. Looks like I've got 33.09, approximately plus or minus 33.09. All right, 14. Let me double check that answer. Yep. All right, okay. Looks like I'm probably going to want to combine those logarithms. So that means I have ln of x minus 2, 3x plus 2. Ooh, this one's going to be fun. I see that because it's going to turn out to be quadratic in the end. Look, I got to multiply those together. So ln of 3x squared minus 6x plus 2x minus 4. All I did was just FOIL that. All right, first, I did inner, outer. Oops. Inner, outer, last. All right, so that gets me ln of 3x squared minus 4x minus 4. And now I can go from logarithmic into exponential. E to the third is equal to 3x squared minus 4x minus 4. Was I mean to? Did I give you a quadratic? I gave you a quadratic formula. I said I wasn't going to. We've got, subtract that over. 0 is equal to 3x squared minus 4x. I'm going to have negative 4. And then I subtract e to the third. Negative 24.09. What did I use? Yep, negative 24.09. And I have to do the quadratic formula. Yee. Opposite of b, plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, go in the middle. 16 minus 4 times 3 times negative 24.09. I'm going to take 4 plus 305.08 divided by 6. So here's my first answer, 51.51. That's kind of a cool number. And then do the same thing, but now for minus 305. That's 0.5. 305.0, excuse me. Oh, so yeah, it was 0.5. Sorry, I'm getting confused by the 309.08. 305.08 divided by 6, which is negative 50.18. Negative 50.18. Wait, something's wrong there. Something is wrong. Something is wrong. Something is wrong. What did I do? Because those are not the answers that I have. Something is wrong. So what is wrong? What did I do in my key? Minus 4 times 3 times negative 24.09. I didn't square root it. That's bad, Mr. Lambert. I didn't square root it. Okay, sorry. Square root that. Okay, that's what I want to add and subtract from 4. This should be 4 plus 17.47. I'm going to round to 17.47 divided by 6. So I've got 3.58. Oh, yeah, there we go. That matches my key. 3.58. And then I'm going to do the minus. 4 minus 17.447 divided by 6. Negative 2.25. Negative 2.25. Now, here's the deal. I'm looking for the x values, right? I would be really happy if we got there, but could I possibly have a negative 2.25 as my x value? Take a look up here. If I plugged in a negative 2.25, can I take ln of negative 2.25 minus 2? No, I cannot. It's a non-real answer. So actually, this is what we would call back in Algebra 2 an extraneous solution. So my only solution is the 3.58. Well, that was fun. That was a cool one. Let's take a look at the next. A bacteria culture starts with 600 bacteria, doubles in size every 2 hours. Find the number of bacteria after 8 hours. Find how many bacteria are present after T hours. Find the amount of bacteria after 15 hours. When would the population reach 140,000? So basically what I'm going to do here, why does this one say, that says 14. Did I have two numbers that were the same? Where's 11? 2 ln x, okay. 12 and 13. 12 and 13. Oh, I misnumbered. No, I misnumbered in the key. Oops. Okay, sorry. And we're back. If you look at my key in the book, or in my key binder, this says number 16 in the key binder. It looks like I skipped number 13 on my key. All right, a bacteria culture starts with 600 bacteria. So F of 0 is 600. F of 2 is 1200. F of 4 is 2400. And I could keep this process going. F of 6 is 4800. And then F of 8 is 9600. So I can answer my first after 8 hours, 9600. Okay, now part B. Part B says, okay, my starting value is 600 times 2 to the, and how much am I doubling every time? T over 2. Okay. Part C. Now, how did I get that? Remember, it's original times, this is kind of like your, how much it's growing by rate. And this is how many cycles it's going through per time. So if I have, you know, 6, for example, over here, that would be 6 over 2. So 2 to the third power. So that's why it's 6 times 2 to the third, 4,800. So there's my function. And now part C says, find the amount of bacteria after 15 hours. So I'm going to say 600. Oh, get out of here. Get 600 times 2 to the, and then it's 15 hours. So 15 over 2. We'll just do 7.5. 108,611. 108, 611.6. Sure. I have 6016 on my key. Sure. Bacteria. And then it says, when will the population reach 140,000? Now, I can do this on my calculator, or I could do this as a logarithm. Doesn't really matter. What I'm going to do is plug it in my calculator. I'm going to say y equals, let me get this out of here. And I'm going to say 600 times 2 to the, and I'm going to put this in parentheses, x over 2. Oops, not times, divided. Come on, x over 2. That's my function. I'm going to zoom 6, put this back into standard. Oh, I do want to do 140,000 actually. I want to make that as my y value because I know that's what I'm trying to reach. I want to know the time that it's going to take that. So I'm going to zoom fit that. Looks like I got to zoom out a little bit. Zoom 3, enter. There it is. There's my intersection. Second, calculate. Intersect is choice 5. And that's going to give me 15.73. 15.73 is my x value. So how long is it going to take? 15.73 hours. 15.73 hours. All right, let's take a look at number 16, which again is it's noted as number 17 in my binder. All right, half-life. Okay, the initial mass is 20 grams. So that means F of 0 is 20, has a half-life of 6 days. So F of 6 is 10. F of 12 is 5. F of 18 is 2.5 milligrams. Grams, just grams. That's part A. Part B, so that's M of T. I guess I should have written it as M of T, but you get the idea. The initial amount, which is 20 grams, to 2 to the negative T over 6. That's my function. And then part C says, when will the mass be reduced to 0.03 grams? 0.03 grams. You could do it as a logarithm, and that's what I show in the binder, but I'm just going to run it on my calculator. So I'm going to go y equals, I'm going to get that junk out of there, 20 times 2 to the negative x over 6. And I want to know when it's going to be 0.03. So I'm going to zoom 6, put it back to my standard window, and then I will zoom fit this. I can see it a little bit there. Zoom fit. I'll probably have to zoom out again, but that's okay. I don't know, am I? Oh yeah, I'm definitely going to have to zoom out. All right, so zoom 3, enter. I bet I won't see my 0.03 coming across the bottom. But I know it's there. Second, calculate, intersect point, choice 5, enter, enter, enter. Oh, I guess I have to zoom out one more time. Zoom 3, enter. If you ever get that no sign change, that's what it means. Okay, second, calculate, intersect, enter, enter, enter. 56.28. Yep, that's the exact amount that I have in my binder. 56.28, the exact amount if I do it algebraically. Okay. Days. Days? Yeah, days. All right, last problem. Again, this is number 17, but number 18 in my book. The table shows the average U.S. retail residential prices for electricity from 2000 to 2012, measured in cents per kilowatt hour. Finding a linear model. So let me go in here, stat edit. Looks like we've got 0, 2, 4, 6, 8, 10, 12. Looks like I've got 7 entries. Is that true? 1, 2, 3, 4, 5, 6, 7. Okay, 8.24, 8.44, 8.95, 10.4, 11.26. Better check 8.24, 8.44, 8.95, 10.4, 11. I got nobody to stop me here if I punch something in wrong. Okay. So here's my linear model. I go stat calc 4. And, oh, there's the bell. Don't leave. It's not your bell yet. So it's y is equal to 0.331x plus 8.073. There's my linear model. And then it says use a model to estimate the average retail price of electricity in 2005 and then 2013. You know what I'm going to do? I'm going to go in and actually plug it in. I'm going to go into my y equals and plug that in that way because this is easier to calculate. Remember, we go in here and plug in vars. Choice 5 is statistics. And then I scroll right twice to EQ to get reg EQ. All right, so I'm going to zoom 6. All right, and now you could either go to your table to find the x value of 5 and the x value of 13, but I'm just going to zoom. Should I zoom out? Yeah, let's zoom out. Zoom 3 enter. Okay, so I'm going to second calculate the value of 5. Pull that over here. And then I'm going to, so my calculate for 2005, 9.72. For 2013, that's 13 years past 2000. So I'm going to go second calculate the value of 13, 12.37 in 2013. And then I want to know, okay, how long is it going to take to reach 15 cents? So I'm going to go 15 cents here, 15 for my Y value. And let's see where it comes out. Let's see if it's on the graph. Oh, let's go. Perfect. Second, calculate intersect. Choice 5. Boom, boom, boom. All right. So it's going to reach 15 cents per kilowatt hour in 2020.9. What would that be? 0.9336. 0.9336 times 12 in November of 2020, back when life was, oh no, that was not, that was bad, that was still bad life. Subtract 11 times third, how many days in November? January, February, March, April, May, June, July, August, September, October, November. 30 days, not 33. So November 6th of 2020. If I'm getting really exact. Subtract 6, multiplied by 24 at, subtract 6.096 times 24. Okay, at 2 in the morning. 2:15 in the morning on November 6th of 2020. All right, that was stupid. I don't know why I did that. I just needed to know this. Oh boy, sorry. I'm getting a little loopy, folks. All right, hope you guys have had a good weekend. Again, it's still Friday for me. Woohoo! So I will see you tomorrow. Remember, test is Tuesday, Wednesday. So long.